Hello friends, uh, we are going to solve these two questions which, uh, which are asked in IIT JAM 2024. So here you see, actually I have not written the options here. Okay, first question, we need to find the value of the line integral for the given vector. This is the vector, and along this closed path, closed path, if you see the diagram. Okay, so now here you see, this is 2 x cap, means here and x cap is nothing but I cap. Okay, and this y cap represents j cap and z cap represents k cap. That's it, don't be confused. Okay, so now let me take a new slide to solve this question. So in order to solve this, we're going to apply the Stokes theorem. So line integral of this vector along a closed path is given by surface integral curl of this vector dot ds vector, right? So we are going to apply that. First, let's find the curl of this vector. So let's find the curl of this vector. Okay, so how to find it? So here we're going to write the x cap, y cap, z cap, sorry, not y cap, yes, y cap and z cap. Instead of k cap, we're going to write z cap. So because I cap, j cap, k cap, instead of those, here x cap, y cap, z cap are used here. So first one, here we have del x, then del y, then del z. Okay, that's how we need to find curl. And here we're gonna have 2, then here yz square, then we're gonna have, just wait, just give me a second. So here we're gonna have 3y plus z square. That's it, right? So now how to find a curl here? So for x cap, what we're gonna take? We're gonna operate these two, right? If you differentiate partially with respect to y, this one, then you're gonna get 3, right? You're gonna get 3, then minus. If you differentiate this partially with respect to z, then you're gonna get 2yz, right? Then you're gonna get 2yz, right? So now for y cap and z cap, you see, for y cap, what we need to do, we need to differentiate this with respect to x, right? So that's gonna be 0 minus, then again this should be we should differentiate with respect to z, we should differentiate 2 with respect to z, this way, right? So that will be also 0, just wait. So minus, here we're gonna get 0 minus 0 y cap. Similarly for z cap, we need to differentiate this one with respect to x. So there is no x, so it's gonna be 0, right? So here we're gonna get 0 minus, so differentiate 2 with respect to y, then that's gonna be also 0, so z cap. So that means curl of this, we have got only this part, this these things becomes 0. So we can write curl of v is this, right? This is the curl we have got. Now you see, if you write in polar coordinates x and, if you write x and y in polar coordinates, before writing in polar coordinates, let me write, let me plug this one in this. Okay, and here you see this curve is on y and z plane. So we can write del s vector is equal to del y del z, and area vector is, this is the surface, and then its area vector will be perpendicular to this surface in outward direction. That's why, so direction of this del y del z must be along x-axis. So here we're going to write x cap. Okay, now if you plug these two here, then what you gonna get? So then you can have integration curl of v dot ds, that's gonna be equal to 3 minus 2yz x cap dot double integration, that means surface integral. Then instead of ds we're gonna get dy dz x cap. So x cap dot x cap, that's gonna be 1, right? So now let me go to the go to a new slide. Let me take a new slide. Here you see. So this is the last step we have got, right? So now what we can do here, you see. So in polar coordinates, here one more thing, let me tell you. So what are the limits of integration here? 0 to 1, this length is 1, right? 0 to 1, 0 to 1, 0 to 1. Okay, so now you see, in polar coordinates y will be is equal to, if you consider this radial vector r, right, r, and the angle theta, so then y will be r cos theta, then z will be given by r sin theta. So we are not going to consider the x because this is on yz plane, so we don't need that. And dy dz, this surface element, this area element dy dz, that will be given by r dr d theta. Let me tell you how. Now you see, suppose if you consider a very small area element, this is the very small area element, and whose area is, suppose this is dx, sorry, not dx, dy, this axis is y and this is z, and this is dy, and this part is suppose dz. Okay, now if you consider this this way, this is very small, right? So now imagine this way, that this area is something like this. Suppose, just wait. This area is something like this. Okay, this is the angle theta. This angle is suppose theta. This angle is suppose theta, and this is suppose dy, and this is dz. So it is very small, so that you can consider this as a rectangle, right? So now you see here dy, this dy, if you consider this is the radius vector r, radial vector r, just wait. Now it's good, okay, to explain. This is dy and this is dz, and if this angle is theta, this is the this is the radius vector r, suppose, and this length is suppose dr. Okay, very small part of this, and dz will be given by, if this is the radius r, then dz will be given by, this length will be given by r theta, right? That will be given by r theta. Okay, r theta. So let me consider this is d theta. Okay, very small angle d theta, not theta, d theta. Then this this length will be given by r d theta, right? This length of this arc will be given by, that means dz will be given by r d theta. Then what will be the area? So dy dz will be equal to dy is nothing but dr, and dz is equal to r d theta. So you can write dy dz as r dr d theta. You can write that way. Okay, So hope you have understood. You can prove this one. The proof I am not going to show this proof here because it's going to be long. Okay, I don't want to make this video very long. That's why I have given the idea, rough idea, that you can understand why does how we have got this. Okay, so now you see, therefore the surface integral of this part will be 3 minus, instead of y we're gonna write r cos theta, right? We're gonna write r cos theta, and instead of that we're gonna write r sin theta. Okay, and as x dot x becomes 1, so we're gonna ignore that. Then dy dz will be r dr d theta. That's what we have got. Okay, so we're gonna integrate with respect to r from 0 to 1. Okay, because length of the radius starts at 0 and ends at 1. Okay, 0 to 1, this is the radius, right? And the angle changes from 0 to pi by 2. This angle is 90 degree, pi by 2, right? 0 to pi by 2 when you integrate with respect to theta. Okay, so now what we can do here, so first let us ignore the limits. First let us integrate. Okay, so integration. So how to integrate this? You see what we're gonna do. Now this can be written this way: integration 3 r dr, right? Then minus 2 can be written outside, 2 integration. So here we're gonna get r dr. Here we should write d theta as well, so I forgot to write that part. So now r square, r into r square, and if you multiply this r, that's going to be r cube. Okay, so r cube cos theta sin theta dr. Okay, then d theta, right? Now let me go to the next slide. Okay, now let me go to the next slide. So here what we can do is, now you see, just let me do a little bit of adjustment here. Okay, now first we're gonna integrate it with respect to r first. Okay, then here you see, let's check what we get. Okay, after integrating with respect to r, so this become 3 r square by 2, and we have to integrate it from 0 to 1 when you integrate it with respect to r. Then this is function of r, so it can be written outside the integral when you integrate with respect to theta. So here we're going to write d theta 0 to pi by 2, that's it, minus 2. Now integration, if you integrate r cube, then you're going to get 3, sorry not 3, r to the power 4 by 4, right? That's what we're going to have, right? And then you see, so if we integrate this from 0 to 1, and with respect to theta we have to integrate it from 0 to pi by 2, right? 0 to pi by 2. Then we're going to write here cos theta sin theta dr, sorry not dr, d theta. Okay, with respect to r we have already integrated, so this 2 cancels 4, so it's going to give you half. Okay, so now on putting the upper and lower limit, here we have got 3 by 2. Okay, then integration of d theta is theta, so 0 to pi by 2, then minus. So here let's put the upper and lower limit. Then what you're gonna get, you're gonna get 1 by 4. and 1 by 4 minus 0, that means 1 by 4. 1 by 4 into 2, that's going to be 1 by 2, right? So integration 0 pi by 2 cos theta sin theta d theta, that's what we have got. Okay, so now you see what we can do. If you make this 1 by 2 1 by 4, then what you can write, if you make it 1 by 4, then you can write a 2 here. So now we can apply 2 sin theta cos theta, that is sin 2 theta formula, right? So if we use that, then what we gonna get? So here 3 by 2, so putting upper and lower limit here, and here we're gonna get pi by 2 minus 0, that is pi by 2. Then 1 by 4 integration 0 to pi by 2, here we have got sin 2 theta d theta, right? So now let me go to the new slide. Let me take a new slide. Okay, let me copy the last step and let me go to the new slide. So here is the new slide. So here we have got 3 pi by 4 minus 1 by 4. If you integrate sin 2 theta, that's gonna give you minus cos 2 theta by 2, right? That's what we're gonna get. So here we're gonna get cos 2 theta, and because of this minus, here it's gonna be plus cos 2 theta by 2, and integration from 0 to pi by 2. So here 3 pi by 4 plus 1 by 4, and if you put the upper limit here, then you're gonna get cos 2 theta. Instead of theta, you're gonna get pi by 2. Here pi 2 to cancel, so cos pi is minus 1, right? So here you're gonna get minus 1 by 2 because of this 2, and minus, when you put 0, cos 0 is 1 by 2. That's what we're gonna have. So 3 pi by 4 plus 1 by 4 minus half, that's gonna be minus 1, right? Minus half, that's gonna be minus 1. And if that is the case, then so you can write this one as, if you take 1 by 4 common, then you're gonna have 3 pi minus 1. So this is the answer. So hope you have understood this. Now let's move on to the next question. In this question, we need to find the divergence of r cap by r cube vector. Okay, r cap by r cube. So r cap is the unit vector of the radial vector. Okay, so here you see how to find the divergence of this. Let me show you. First, you have to consider the divergence of the spherical coordinate. Okay, suppose we have a vector in spherical coordinate. If it is in spherical coordinate, suppose VR. So in spherical coordinate, we used to write the function vector in this form as a function of r, theta and phi, right? Okay, so now let us consider this vector VR r cap plus v theta cap, suppose, and v phi cap. Okay, so, and in spherical coordinate, this divergence of this vector is given by 1 by r square del r of r square vr plus 1 by r sin theta, 1 by r theta, 1 by r sin theta del theta of sin theta v theta, right? Then plus 1 by r sin phi del phi of sin phi v phi. Okay, so now here you see this vector. If you compare with this one, here v vector is nothing but r cap by r to the power 3, which can be written in this form, that 1 by r cube r cap. So that means the other two components are missing here. That means you can consider as 0. Okay, so that means we are to deal with only this part. Okay, right? Because there is no theta, no phi. Okay, so how to do that? So divergence of this v, here v is nothing but r kept by r cube. Okay, that's going to be equal to, according to this, 1 by r square del r of r square. Vr is nothing but this one, 1 by r cube. Okay, 1 by r cube. That's it. Okay, that's how we can solve. So now you see, this r square cancels r cube to give r. So here we have got 1 by r. So derivative of 1 by r with respect to r, that's going to be, this is r square, and that's going to be minus 1 by r square, right? Because we know ddx of 1 by x is nothing but minus 1 by x square, right? So hope you know these things. So that's why the answer is going to be 1 by r to the power 4. This is the answer. So hope you have understood. Thank you for watching. See you in the next video.